Use logarithmic differentiation to find the derivative of y equals 1 over, and it'll be x times x plus 1 times x plus 2. All right, so I do give you a method here, right, to use logarithmic differentiation. Okay, now, can we solve this the normal way? Well, yeah, we can use the quotient rule here. Okay, so we can use the quotient rule because this is a quotient, it's a fraction, right? But then you got to use a product rule. So I mean, it's doable, okay, but probably be a little bit more difficult, right? But here I tell you to use logarithmic differentiation. What does that mean? Okay, the first thing we're going to do is we're going to take the natural log of both sides, right? And which that's legal. We can do that because whatever we're doing to one side, we're doing to the other side, right? So we'll take the natural log of y, which is equal to the natural log of this whole thing. So we got 1 over x times x plus 1 times x plus 2. Okay. But what's the whole point of doing that? Right? And the reason why we do that is, well, wait a minute, this is a log expression. We can use the properties of logs to expand this guy. Let's take a look at what happens, right? When we properly expand this, right, we get ln of 1 minus, right, because these terms are in the denominator, right? So minus ln of x minus the ln of x plus 1 minus the ln of x plus 2. Okay. Now we can take the derivative of both sides. Okay, now once again, you got to be careful. We are taking the derivative of both sides with respect to x. Okay, so here we do a little bit of implicit differentiation. We assume that y is a function of x, so we got to use a chain rule on this guy. Okay, so well, remember, what am I talking about here? We're taking the derivative of this whole thing with respect to x. Okay, so what happens when we take the derivative of ln of y, right? Well, that's 1 over y, but then by chain rule we need to multiply that by dy dx. Okay. What is the derivative of ln of 1? Well, ln of 1 is actually just 0, right? It's just a number, so that really just goes away. What is the derivative of ln of x? That's just 1 over x. The derivative of ln of x plus 1 is 1 over x plus 1 times 1, but we don't need that, it's just a 1. And then 1 over x plus 2. And finally, this is not the final answer, right? Because we want to find dy dx, so we just multiply both sides by y, right? We're going to just bring this guy sort of back over here. So dy dx is going to equal y times all of this. I'm putting it in brackets here just because I could have put it in parentheses, I guess. And I mean, technically, I guess you can leave your answer like this, but we do know what y is equal to, right? Y is equal to this guy right here. So we're just going to put that, right, y, which is 1 over x times x plus 1 times x plus 2, right, times this whole thing, negative 1 over x minus 1 over x plus 1 minus 1 over x plus 2, right, and that should be our final answer. So in this case, using logarithmic differentiation was actually, it turned out a lot easier. I mean, the final answer looks a little bit messy, but it was a lot easier to compute.